Well, Kenny, how's it going? All right, let's see. So today, I'm not sure what we're doing. Basically, I'm deleting everything again. Almost everything. And we need a new solution. I think I have one, but I don't know how to implement it because it sucks ass to do. Basically, the way we are doing this right now is just horrific. It honestly is. I don't know why I've been pushing it for as long as I have, because it's just not good. Hold on. It's too loud. It runs like shit. The code looks like shit. It's just shit. Like, honestly, this is not the way. This is just not the way. Just isn't. And I kind of knew that. I just wanted to see if I could get it to work and try it at least, see how it went. But it's total ass. It's total ass. Basically, right now I'm drawing a cube by using additional vertices in order to fix a bunch of edge case drawing issues. Where in certain scenarios, drawing a triangle like this means that you actually want to render like this, and then it doesn't work, right? And this fixes that, because now you can just render like this instead, and every edge case is fixed. But it's also like 4 times as expensive to render this. And the code is just a nightmare. So what I'm gonna try next is a sort of marching cubes approach. And I have looked at marching cubes, and I think I need to make my own version of it. Because there is like a triangulation chart that you can use for marching cubes, but it's very specific in like how the implementation works. Because you end up with cubes that have like a top part like this, and then at the bottom you have like a shape like this. And that's just not something I mean to have. Like this is for a specific implementation, and I'm not interested in this type of scenario. So instead, what we're gonna do is, I think we have, I don't know how many exactly. I think we have 4 or 5 shapes. Because you have a normal square, right? Or a normal cube. You have a slope. And you have an outer slope and an inner slope. And that's pretty much it, I think. The question is just here, a cube. Should a cube aligned to a... Should a non-aligned cube and an aligned cube be two different things? I kind of think yes. And in that case, then this should maybe have a couple more variations. Because this is just an aligned cube here, right? But what if it's an aligned cube to there? And an aligned cube to there? I'm not sure if I want to do that. I don't think so. But basically, right now what I'm trying to do is I'm trying to create a voxel terrain, and I want to connect each neighboring tile together to form a smooth surface. And I want each voxel to have an internal volume, so that it's not just an empty voxel or full voxel, but it can be anything in between. And that's the trickiest part. Otherwise, I could just copy paste in marching cubes right now and just do that, and it would work. But instead, I want to try using a marching cube setup, meaning you kind of just index every configuration that exists. And then you like load that. You store that as a number of inputs, or you store that as a value, an index. And then in the shader, you just set it up and you just like fetch the index configuration or the vertex configuration. But is this what people solve with octrees? No, people don't generally do this. There are many, many solutions to this already, actually. But most of it doesn't really include the thing that I want, which is volumes in each voxel. Otherwise, there's plenty of techniques that they use in medical science for... And that's what marching cubes is. They just iterate over the cubes and then give them a number based on like what neighbors it has. And then when they render that, they just fetch the configuration based on what the data already said. Because right now I'm trying to render it on the fly. Like every time I find a voxel with the ray, I read all of its neighbors, and then I calculate the shape, which is extremely heavy. It's not a good solution. It's like the worst solution you can have. It actually works pretty well on a 4060 Plus. When I was just using a cube with 8 vertices, but there are so many problems. Plus, even then, it doesn't run that well. Runs pretty well, but not that well. And octrees are generally for rays. I don't know how common octrees really are when it comes to ray tracing, but what you saw with that is empty space. That's called an acceleration structure, and that's what you use octrees for. There's also something called the brick map, which is kind of just a simplified octree. That's what I'm using. And it's basically like if the top level is empty, then you can just skip to the other side of it. Pretty much. Oh, I have to be honest, it's like setting all of this up has been such a pain in the ass, and now I'm like How do you write to a new branch? What is this? This is big quad. I don't know how Git works. I mean, this is just changes, right? I don't know. Whatever. Big quad. Switching to marching cubes. Because the hard part, or the easy part, is... I don't really know how I would do this, but... It's basically just writing a function, I think. I don't really know how to write this, because I don't really know what the best way to handle various variables and memory and stuff is for HLSL. But I feel like you basically have to do something like get voxel configuration, and then that needs an index. And then in here, it's just going to be if index equals 0, then return float 3 minus 1 minus 1 minus 1. And then I have to repeat this. Wait, no, that doesn't make sense either. What am I... I mean, I feel like I basically need to return an array or something. But because this isn't right. This is the rotation. Because what I was thinking of doing was just storing the basic shapes and then using a matrix to rotate it properly. But even then, like, even if I just have this shape here, like this, and I can just say, okay, this is shape number 3, and I just fetch that. I still have to create this shape on the C# side. And how do you do that? I have to check like every side for a certain setup, and then I have to check every rotational type, or every rotation has to be checked, like, is this that? And then it has to be assigned to like index 3, which is this shape. And then it has to have like a standard rotation, which would be like this. No, it would be like this. Then go down there. So it's pointing to the left, down, and towards. That's the default. And then we use a matrix to rotate it from -1, -1, -1 to whatever else it should be, like -1, 1, -1, or whatever. That's the idea. Ultimately, having every single rotation of every single type is better, but I also don't know if it's gonna work in the first place, so doing it the worst way feels better. To start with. But here then, the people over in the DirectX Discord did not seem to like the thought of having global variables, but that's kind of how I see this best done. Having like a bunch of vertices set as global, and then you just set them to a certain value using this. Because then I could say index 0, and here I set like vertices 0 to 4 to certain values. Otherwise, like, how would you do it? It would have to use some kind of array, and anytime I've tried using arrays, it kind of sucks. Arrays are not very useful in HLSL. They're like just extra weight. It's not like in C#. In C#, the array is basically free, while here it eats up registers, and it's like it's just slower. I actually kind of have the alignment here already. What if we HLSL marching cubes? What if we Google that? Marching cubes terrain generator. Marching cubes. GSPSVS. That int edge table. Huh. Here he is inputting max vertex count. In-out triangle stream. HLSL triangle stream. What the hell is that? Oh, come on, bro. What is that? Stream output object. Triangle stream. Okay, there. A sequence of triangle primitives. It is something here. Stream output object is a templated object that streams data out of geometry shader stage. Out of the geometry shader stage. I do feel like I should move away from compute shaders a bit. Because right now I'm basically completely rendering the game in compute shaders. I'm not using regular shaders at all. And I think that's probably slower. I don't think it's much slower. I don't think it really matters, but I don't really know either. Because I am rendering to a texture and then I render the texture. And there's really no reason to do that, I think. How does this work? Find the vertices where the surface intersects the cube from the edges using trilinear interpolation. I'm not really sure I understand. Honest. I don't know what this is supposed to be. Geometry shader, pixel shader, vertex shader. Oh gosh, how goes the Raymarching? Terrible. Terrible. I actually barely know how the regular shader pipeline works. Because you got geometry, pixel, vertex. Isn't the pixel shader the last one? I think so. Vertex shader. Where's the edge used? Like, he's got an edge table here. But what? This is a marching. This isn't my code, by the way. But this is marching cubes. I don't know why he wrote it in hex. Actually. Edge table. This is where he reads it. Okay, it is in here. Void main. If cube index does not equal 0 and cube index does not equal 255. Okay. Hmm? So he's checking if the bits are true. I still don't really understand why he wrote it in hex, but it's probably just to keep them similar size. Instead of having values like 12 million over here, or whatever. Because there are up to 12 vertices. And the values would still be pretty small. Or maybe, I don't know. I don't know why they did that. Computer science guys, they're weird. I'm just not sure what they're doing here. Find the surface intersects where... Try linear interpolation. Says the programmer. That's damn straight. I don't understand what this is. Isn't marching cubes just... Like, why does it need interpolation? I thought it would just be an index and then you just get the vertices. Wait, there was this guy. Because the way I was imagining it was basically just loading a couple of vertices. So if this is the shape we need to load, then we're just gonna load the vertices. Like, we're gonna load... Because this one would take... Let's do this. In this scenario, I wouldn't actually need to render the back face, or I wouldn't need to do any checks on the back face of these two, ever. So in that scenario, I wouldn't need to load as many. I would need this vertex, this, and this. I think. And then I need to turn this into triangles by rendering like that. But this is the annoying part with this approach, where there's gonna need to be like so much manual shit. So maybe I should just use all the vertices anyway. But it's still not so easy, because one of the core issues that I'm having is that this shape here is fine. In this, well, it isn't. This shape is actually completely broken. Because assuming that the cube is always constructed the same way, like this, here there's also like that, and then over here it would be like that, right? And back here it would be like this. That way, hold on. Whatever. If the vertices are in this configuration on this side, that means that you can't do this. So you have to, based on the shape that we need to create, the vertices need to be arranged in a certain manner. And that's what's a little tricky, I feel. But as long as like 0, 3, 1 render the first triangle, we can just change the triangle to be here by setting that like 1 is... Yeah, like just saying that 1 is over here instead. That way the triangle has been shifted, right? So as long as we do that, we just say like, we count how many triangles we need, and then we set an this is not the kind of music I wanted to have. Need to make a new playlist. I just make a bunch of triangles, right? And then I have an index that says that like counts how many triangles we need to render. And then we just set up those triangles to render the shape correctly. But this is gonna be so difficult. I barely know where to start. My initial thought was to just so this would need to be how do you make this return? How do you make a function return an array? How does this work? Or should it be an out? HLSL function return array. You can't return an array. Return a structure with the array in it. But there is that in-out triangle stream, which is probably the way to go here. I'm not sure. Use in-out? Yeah, something like that. Wait, where did my define go? I think something like that. In-out sounds to me like a pointer. I mean, something like that. And then here, for example, It would have to be something like test 0 equals. Just as an example to try to figure this shit out. This would be float 3 -1 -1 -1. Test is 1 equals and see this is what I'm afraid of. This is what I'm afraid of. And then this is -1 1 -1. And if we just make a slope, then the next one would be -1 1. And the next one I'm not even sure it would need this many. I think the 0 wouldn't exist. And this would be -1 1 1. And yeah, 0 wouldn't be there. And then there would need to be an out bird count or something. Bird count. Five. And then if we look at this, right? Basically, it depends on how each shape would be drawn in practice. And if this is a slope, let's draw it this way instead, just so it's visible. If the slope isn't ever actually going to render this side, because that would make it be this shape instead. Right? That means that we only need to render this face. And because of that, we only need this, 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 and this. And even so, I have too many. Yeah. I don't know, whatever. So that should just be 4 vertices then. And then I use a matrix to rotate them. And then render. That's the current working theory. And that means I have to set up this for a couple of configurations, which shouldn't really be that many. but there are some. I think this might be all of them. We've got a concave corner, convex corner, slope, aligned cube, aligned in one direction, aligned in two directions, aligned in three directions. And then just cube. Unaligned cube. So 7 of these. And then I need a matrix. And then the most difficult part. These vectors are kind of wrong. Yeah. And no. It's supposed to only be 4 here. And then you do that, and then I return nothing, really. Because this has several benefits. I think the rotation is gonna be bad. That's gonna eat up a lot of performance. And that's why ultimately it would be best to have an index for every rotation as well. But I think that's something you should generate. You shouldn't sit there and write those. That should be generated. But I don't feel like doing that. And because, like I said, this was my previous solution. This is dog shit. This is so awful. This is so many vertices to draw a cube. That's not the way. But I was desperate. I was desperately trying to get my previous solution to work. And it does work. It actually does work. But it's just so horrible. And it runs super, super poorly. But again, the issue is going to be setting all of this. Because reading the index and extracting the correct configuration from that, that's easy. But setting them, that's gonna suck. Because I feel like I'm basically gonna have to write a function to test for each of these scenarios. So first we have to check for concave corner, and then we check that in every rotation. Because I won't be able to like rotate it into like a standardized position, I think. That won't necessarily work. Or maybe that could be possible. I think basically the way I'm doing it right now is that I give the voxel an alignment, and the alignment represents an alignment. But it gets an alignment of -1 or 1 in each axis. So if it has an alignment x of -1, that means that it's connected to a voxel on this side, but not on this side. Because if it was connected on this side, then it would be 0. Like if both sides are connected, it's 0. I wonder if I should give it an alignment of like minus. No. That's the tricky part. Like we have an alignment of -1, which is here, and then an alignment of 1, which is here. But an alignment of 0 means that it's both aligned and non-aligned. So it would have to be like aligned left true, aligned right true, and then both are true, that means we're surrounded. Both are false, then yeah, I don't know. Because the -1 +1 thing is actually relatively useful. For mathematics. I'm just thinking. Because the difficult part as well is that there's gonna have to be a lot of code as well. Like, if I load a slope, then I'm gonna have to check this and this against all 3 of its neighbors, like this, in order to create an average to set the y of this vertex. And the same for this. But that's like that needs to be a specific set of voxels that we're checking here. And if then 1 is rotated to be where 5 is, you know, that becomes very complicated, I feel like. To determine which voxels to read in order to create an average. Because otherwise, if it's like this, then I know that 1 is always down here. Another option is to, instead of saying that we have vertex 0, 1, 3, and then just doing it like that, we can specify which voxels we're using, or which vertices we're using a some kind of bit mask. So it doesn't have to be in a linear fashion. It could be like I'm using 0, 7, and 5. But the issue with that is that now we're no longer using strict triangles. Because that's a way to set the rotation, kind of. Because then if we set this slope here and it has this rotation, then we use 1 and 5, then I know that 1 we only need to check here, 5 we check here. And if it's rotated here, we end up using 5 and 6 instead. But the issue with that is that the actual triangles that I need to make become dynamic at that point. Whereas here, we just need to create a triangle from 1, 1, 3, and 1, or 0, 3, 1. And then these can be anywhere we want, really. Because what it means is basically that I'm gonna have to have an index, and then it's gonna say like if index equals 2, then we have to check if rotation equals this and that, then we're gonna use this, and it's gonna become a huge tree of if-else statements for every shape. Which might be okay, honestly, like, it's kind of whatever, I think. It's just a lot of code to manually write. It could be possible to like plug them into an array too. That way we could like sort and order the indices any way we want in the array, just to assign them to the triangles. I don't know if it really changes anything. I'm just thinking. I don't know what I'm thinking though. I feel like there's maybe not in graphics programming as a whole, but for like what I want to do here, I feel like every single solution is just dirty as shit. Like it just turns into like infinity code and setting specifics, which is what you don't really want in graphics code, but whatever. It's just 10 years ago, like writing branching code was just like a sin. But the GPUs are a lot better at it now, so it's really fine now. But it's still like the actual coding language is a bit special. I do feel like setting this as globals is probably better, but I'm not sure. I feel like we just gotta start somewhere, right? Setting a whole thing here, or setting a whole cube. We just gotta do this. In which case, this is -1, -1. 1 is that. This is 1, 1, -1. 3 is 1, -1, -1. 4, -1, -1, 1. 5 is -1, 1, 1. 1, 1, 1, and 7 is -1 there. So this is a cube. Can you write +1? Is that like valid syntax? Writing +1 instead of 1? Because that would almost be useful. And that's what we're doing lockpick, for sure. That's that there. But I feel like there are still like UV issues as well. It's just changing like which vertex is which, I think is gonna completely destroy UV mapping. And then here somewhere. Here we're fetching all the voxel data. But this here too, we could spare ourselves some loading here as well. But I just feel like there's no way of dynamically doing that in a good way. Get voxel configuration. Here we need an index, we need the array. I don't know what I called it. Box array. It's not even, that doesn't even make sense. Well, sure, whatever. There's something called volatile, but the docs say that it doesn't do anything, so I don't know why it exists. Here it says, volatile. Mark a variable that changes frequently. This is a hint to the compiler. This storage class modifier only applies to a local variable. Note, HLSL compiler currently ignores this storage class modifier. So it doesn't matter. Maybe that's like a remnant and it doesn't matter anymore. But then you do something like this, right? And then you get the voxel config and all of that. And I guess that would be useful for really flashy things. It would be useful for any, like... It's just about changing numbers. Because I don't know exactly how it works, but it seems like writing repeatedly to the same variable isn't the same as it is in C# or in C languages. So repeatedly writing to like one variable is bad. I think it eats up registers or something like that when you do. I'm not sure. I've just recently started paying attention to registers and stuff like that. But then here's the issue here. Now we need to do something like if int index and then if index equals 0. In this scenario, we don't really need to do much, though it's not entirely true. We do need to rotate, potentially. And that's because even if it's a single cube, the cube might have a rotation. And if it has a rotation, then that's gonna potentially affect what is rendered on it, texture-wise. Because the texture could have a front and a back and a top and a bottom. But that's not something I've even begun to look into, because that's like there are like two different kinds of rotations. That's like a true rotation. Well, what we're trying to do here is there's like a true rotation and there's a vertex rotation. The true rotation is if the block itself is rotated in a way by the player or whatever in order to face a different direction. While the vertex rotation is just a way to decompress the vertex configuration. Now, to be frank, I actually don't think that there is gonna be a rotation for like ground tiles and stuff. But we'll see. And like get here in the voxel configuration. Yeah. So this would need a No, it should still work. Because as long as the vertices are relative to each other, that's what counts for the triangle to render. Because the triangle has to be read counterclockwise. And so what I need to do is I need to rotate these values using a matrix to face the correct way. But I think in reality, we need to start over in the C# code. Basically, every time a block is placed, it needs to recalculate its configuration. And we are already setting alignment. So I think and this is, I don't know. Because I feel like I have to do something like if the alignment matrix just Boolean. No, I don't think this is good enough anymore. Actually, no, this is good enough, I think. We're gonna have to say if alignment matrix 0, 1, 0, no, 0, 1, 1 is true, that means we're checking the left side. Or rather, that means that the left side is aligned. No, it doesn't mean that it's aligned. I do have this already set up. This is a bunch of different voxel alignments, but actually, yeah, could I use these? think maybe, and here I'm flushing it into the volume contents. So if I just change this to be public voxel alignment, if I just change this, then we can say if voxel alignment equals voxel alignment let's say 0, 0, 0, 0. This actually means wait, am I stupid? Cube isn't actually a real shape. I mean, it could be, because there I intend to have two different types of shapes. One is sharp and one is malleable. And the sharp one would be more, you know, just a cube shape that's aligned, while the other one is gonna be, you know, like this. But this shape, for example, this shape can only happen in one circumstance. That's if the y-axis is aligned down and the z-axis and the z-axis and the x-axis are not aligned. They're 0. This can only happen in that scenario. So if one axis is aligned, then what we have to figure out, we have to check its surroundings. So if we are aligned down, then if this corner, this corner, this corner, or this corner is empty, then we need to do this here. If only one corner is empty, then it's this shape. If two corners are empty, it's another shape. And there is actually a third shape here, which is if the opposing corners are empty. Because then we could get a shape like this, which I haven't actually really thought of. I guess that would be okay. Down there, and then up on that side. Like a wedge. And this is actually a necessary shape. Maybe. Is it? Is this a necessary shape? Maybe. There are two ways to decide what to do here as well. Either you do this or you do this. And it's either a canyon or a bridge. And what decides which one to use? I don't think there's anything that can decide that. I think you just have to decide. I think probably canyon. Maybe. Because this has a voxel here, 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 and here. And then it's empty here and here. Perhaps. Think like that. And next, should just be a simple one. But here is where I'm gonna get upset, because I'm gonna have to do some shit here. So here we want a simple alignment. And that's gonna be 0. Or, and we're gonna have to make so many ores. Not that many. But like this kind of alignment is when we are aligned in one direction only. So but it's not as simple as that, because now we have to make a bunch of checks here for each alignment type. And that's what I don't want to do. Oh, it's so bad. Because we're gonna have to do something like if voxel alignment equals voxel alignment. Let's go with one that makes sense. 101. Then we're gonna have to say if voxel if alignment matrix zero, one, one, and because here we don't know. Now we have checked that we are surrounded on every side, and if that is true, then we can check if alignment matrix 0, 1, 0 0, 1, 2. Two, 1, 2. Two, 1, 0. And then if the last one here is false, then that means that we are this shape. And we can say configuration index equals 2. Let's say that's 2. And we then need to set a vertex rotation. And in this case, if 2, 1, 0 is empty, that means we have a vertex rotation of... Oh no, there's no flow 3 here. And this should be an int, I feel like. So this is now a vertex rotation of but this is illegal, by the way. Having a vertex vector 3 int in here is actually horrendous. It should not have that. Because the vertices, even on the C sharp side, they eat up so much memory if you're gonna have a lot of them, that you can't afford to do that. It actually needs to be, I think, 6 bits. And those bits just represent -1 and +1. But for now, like, whatever. So the vertex rotation would be -1, or the default one would be -1, -1, -1. That's what we're supposed to be looking for. And in this scenario, we are shifting the Z, is where it's supposed to be that it slopes down to 7. So both of the walls are in the negatives, and so is the bottom. So the fact that this is facing up here means that the Z has shifted to a positive value. And then if this were like up at 6, that would have meant that the Y was shifted. And if this was on this side, that would have meant that the X had shifted. And that's how we're going to get our direction for this. And then when we load them, they're always going to load as -1, -1, -1. And then I'm going to rotate it to the direction that it needs to be. That's the idea. At least. And then here we're just going to set this to be -1. But you see why I am hesitant. Because this is just 1. And I'm gonna have to do this for every single setup pretty much. And I don't know how else to do it. Because all of the configurations need to be indexed. This is also going to make generation way slower and loading slower as well, I think. Well, not necessarily. It depends on if I store the data or if I calculate this on load. It's not a lot of data to store, but it is data to store. This needs to be set 4 times. And the exclamation mark needs to be at different alignments every time. And then the rotation needs to be set for each. And then this needs to be repeated six times. So if I could write this in a better way, it would be better. Like if I could automate it to some degree, but I don't know how I could possibly do that. Because the shape in and of itself doesn't like create a real rotation. So there's no way to test this against a pattern. I mean, there is. I can imagine that there is a way, but I don't know if it's easier to write that than to just do this manually, the shitty way. And just do it one shape at a time, slowly. Because if we start with like a square, and then we set that square up, and then we see if we can render a square using this method, that's step one, right? And then we can connect two squares, then we can create a slope. And then we can create every shape that we need. But see here, I want to say else if on each of them. And then we need to continue, I think. Because here we're checking that, but because I feel like here pretty much everything no. 3 shapes stem from this voxel alignment. Just a flat top, concave shape, and the new canyon shape. But I don't know if I like the canyon. I might just do a square here, I don't know. Because I think if I do the canyon, then I almost need one that looks... But that's an illegal... Yeah, I can't do that anyway. But I almost feel like if I do this, then I need to have another one that's like, if it's empty on every side, but it's connected in every... But no. Anyway, I don't know why I'm getting hung up on this one. It doesn't matter. This is an edge case, and it would work fine if this was just like square, more or less, I think. I don't think it would actually, but more or less. Because what it would mean is that if we have this shape here, and then I dig on the other side, it would mean that this would pop up and become a square. It's like I understand what I need to do, I think, more or less. But it's like you need to go on a walk and you know that the destination is the entire length of the Great Wall of China. And it's like and then the thing is I don't know if when I get to the other end of the Great Wall of China, if the grocery store is gonna be closed. And I'll just have to go back. That's why we should at least just try to start with one shape at a time and try to render that. I at least have all the math I need ready and finished. Because I don't think I should calculate everything. Like, an aligned cube like this, for example, it has the benefit of being able to completely omit this vertex here. And if I can do that, that means I can omit 1, 2, 3, 4, 5, 6 triangles. And not having to calculate 6 triangles is huge. But I don't know if I want to do it that way, because it's actually quite fast to do that anyway, and a single cube is extremely rare, so it doesn't really matter that much. And even continuing from the single square, like, there's just so many things. If I don't do a square the way I did it before, using an alignment and then just calculating everything, then that's where things are gonna blow up really badly here. Because then I'm gonna need to have like one shape for a single cube just attached in this direction. I'm gonna need for a cube attached in both directions. Okay, maybe I don't need that many. Cube attached in one direction, cube attached in 2 directions. Is a cube attached in 3 directions. Then that should just be surface, I think. And then the cubes attached on the sides need to align to that. Instead. lot to think about. But here, for example, this would need 2 more checks here. And then this needs to be 0, 1, 2. What is that? That's bottom left, or left away. And this... So it would need to be like this and like this. If these are true, then this is now configuration index 3. And here, for this one, there are actually only 2 rotations. Because this one, you can see here, whether you flip this in X or Z, it's the same. Like, it can only look like this or like this. So we only need to flip it in like X or Z there. It doesn't matter, I think. Until I have like true rotations. But it does need a Z rotation. But right now we are in... or in a Y rotation. But right now we are here, which is voxel alignment VA 101, which means it is only aligned down. And then if we make it past all of these, then we need an else. That's gonna say configuration index equals 1. Not gonna say that there. And this is then a proper vertex rotation of -1, -1, -1. Because then this is kind of like... Because what we're ending up with there is actually a surface. Like this. And this being aligned like this, the bottom right corner, it kind of means that if we flip the Y, then this is facing down. Like, this is facing up now. We flip the Y, it's facing down. Actually, don't know. Does this work? Because in a way, this is the same shape as, like... as like this, or as this as well. Here it's more like this needs to have a normal almost. And then we rotate the normal. And in that case, then this needs to have like a default normal of like 0, 1. Okay, yeah. No, it So that means that each rotational axis needs to have 3 bits, I think. No, 2 bits. 2 bits for each axis, kind of. Because then we need to be able to say whether it's -1, +1, or 0. And then -1 is not necessarily gonna be the default. But something needs to be. It always needs to have a direction. Maybe we just set it to like up. Up is the most relevant direction anyway. So everything points up. And then we need to point it in a different direction. I don't know if it's gonna be that simple. Does each need 4? But if we need 4 for each, then 2 bits would also be okay, I think. I don't feel like it makes sense. But I think it does, maybe. No. No. It just needs to be what I'm saying. But for this to be pointing up, I feel like 0 is bad. What does that mean? No, 2 plus and minus should be enough. It's this that's fucking with me, right? I don't know if this is gonna be good enough. Like, if I want this to point in this direction, then this needs to be x equals 1. Yeah, no, it's... No. See, it needs to have global rotation and like local rotation, because just by doing this, by pointing it here, I can't rotate it around its own axis. That's the problem. Because if this is pointing in this direction based on the rotation axis, then if I set y to 1 as well, then it wouldn't point here. It would point like this. And that's the issue. It needs like Euler angles or some shit. Then they wouldn't have a direction, and then what? Oh. And that's where it needs a direction. But the direction can be condensed into an integer. In the same way that we're doing this, we can just say what the direction is. And then we can have 2 bits for each axis, which operates as Euler angles, I think. Because then you can say that X is rotated 3 times. In this scenario, then the green part would be on this side, because it would have rotated. The first point is a rotation, so it would be like this at actually 3 would be the maximum. 0 is the first rotation, which is pointing in this direction. 1 is pointing in this direction. 2 this, 3 that direction, right? And this is necessary because if we have like a diagonal, this can be rotated in 8 different directions. Even more if we include the Z to be able to rotate the actual texture. Well, you would actually just rotate around the direction. Because if you have a direction, you can't rotate the X because that changes the direction, right? Oh, you can if it's just like a local direction. That doesn't make any sense. Oh. But sure. What if every voxel just points up by default and we then rotate it using X and Y and Z? This is fucked. I think I'm gonna go and make food. And ponder this a bit more. I wasn't really expecting to be able to do much this stream. I just wanted to get to do something. I'm gonna make some meat sauce. I need to go to the store and buy onions. It's over. Yeah. Until next time, thanks for hanging. Have a good day. Bye-bye.